In this video, we'll discuss the method called integration by parts. This is a method which we can often use when we should integrate a product of two functions. The video will also include a few examples where we use this method, integration by parts. If you remember from when we discussed differentiation, we talked about how to find the first derivative of two functions being multiplied. Let's talk about a function u and a function v which are multiplied, and we should find the first derivative of these two functions multiplied. So that is u times v dashed. Then how we did that was we found the first derivative of the first function u, multiplied that with the second function as it is, and then we added that with the first function as it is, multiplied that with the second function differentiated. As you know, when we integrate, we do the opposite operation. So therefore, if we integrate u dashed times v plus u times v dashed dx, what will I then get? Then I will obviously get u times v. So if we split up this interval into two, which we are allowed to do, as you hopefully remember from when we introduced integration, then we could say that the integral of u dashed times v dx plus the integral of u times v dashed dx must be equal to u times v. So if I subtract my u dashed times v dx integral on both sides, then I get that the integral of u times v dashed dx must be equal to u times v subtracted with u dashed times v dx. So if this integral is easy to find for specific assignment and we know how to multiply two functions, then we can actually easily find the result of this integral here. And that is exactly the method which we call integration by parts. Yes. Alright. As I said, I've brought along a few examples to illustrate this, then I also think it will make a bit more sense. So let's try to look into the first example where we should find the integral of x times e to the power of x dx. So up here I have written the general integration by parts, so we can refer to that during this example, which will be to find the integral of x times e to the power of x dx. So to begin with, we need to define which function we call u and which function we call v of these two functions here, x and e to the power of x. We have two general rules of thumb, and that is that you should pick the function which you will label u to be the function which is easy to differentiate, and preferably easy to differentiate to a constant. We'll see later why. And the general rule of thumb concerning the function v is that you should label the function v, which is the function easiest to integrate. So in this example here, if I should label the function u, which is easiest to differentiate, I think I will go for x, so u is equal to x. And the function v dashed, the function should be that should be the function which is easiest to integrate, so that will be e to the power of x here. Alright. So then if I should integrate my e to the power of x to find v, that will be equal to the same function e to the power of x, as you hopefully remember. And to differentiate u to find u dashed, that is x differentiated, which is equal to 1. Alright, therefore we are now ready to go into the integration by parts method now that we have defined u and v. So according to what we have up here, u times v dashed, u being equal to x, v dashed being equal to e to the power of x, dx is equal to u times v, u is equal to x, times v, which is equal to e to the power of x, subtracted with the integral of u dashed, which is 1, times v, which is equal to e to the power of x dx. So now we're almost there, because now we see that this integral here is something which is easy for us to solve, because we only have the integral of e to the power of x, which we know is equal to e to the power of x. So altogether we have still the x times e to the power of x, which we have here, subtracted with the integral of this, which is e to the power of x, added with our integration constant c. So that is the result of the original given assignment. The integral of x times e to the power of x dx is equal to what we have here, which we could simplify a bit as e to the power of x times x minus 1 plus c. So that was the first example. And as always, you can check your result by finding the first derivative, and then you should end up with the original given assignment here that you can do on your own. So the tricky part is, first of all, to define u and v in an efficient way so that we can make use of the integration by parts method. Let us look at another example. In this example, you have chosen to include is to find the integral of 2x times sine 3x dx. As we looked at in the first example, what we have to do to start with is to label which one of the function is u and which one of the function is v dashed. So our rule of thumb said to us that we should pick the function which is easiest to differentiate to be equal to u, so that must be 2x in this case. So u equals 2x. We differentiate u dashed will be equal to 2. So that means v dashed must be equal to sine 3x, which is the function we can integrate, and by doing that we remember that, or we see that we have a composite function here with the external function sine x and the internal function 3x. So when we integrate sine 3x, that must be equal to minus 1/3 cosine 3x. So now that we have labeled u and v, we are able to jump into the general statement up here for the integration by parts method. So that must be equal to u times v. U is equal to 2x. V is equal to minus 1/3 cosine 3x, subtracted with u dashed, which is 2, times v, which is still minus 1/3 cosine 3x dx. We'll just put in a line here so we do not mix it up. Alright. A constant we just move outside the integration sign, so we get, when we put these together here, minus 2/3 x times cosine 3x minus 2/3 integration the integral of cosine 3x dx. So what is that? Well, minus 2/3 x times cosine 3x minus leaves me with a plus 2/3. 2/3 times, and then cosine 3x must be equal to 1/3 sine 3x. When we integrate that, added with the integration constant c. So now we're almost there. We just need to simplify a bit. We have minus 2/3 x times cosine 3x plus 2/3 times 1/3 must be equal to 2/9 sine 3x plus c. So now that we have solved this rather complex assignment to start with using the integration by parts method, figure out that the result is what we have here. And as always, when we integrate, you can check your result by finding the first derivative of your result given here, and then you hopefully should end up with the original assignment given. So that's always a good check to see that you haven't done anything wrong. So that I think you can do on your own. Sometimes you're not that lucky that one of the function's first derivative is a simple constant, as we have seen so far. But that's not a problem. What we simply do is that we continue to do integration by parts. So at the very end, we will end up with one of the functions differentiated will be equal to a constant. Let's look at one example with that is the case. The example which I have chosen to bring along here is we should find the integral of x squared times e to the power of x dx. So we do the same thing to start with as we did in the other examples. We define u and v, u to be the function which is easiest to differentiate, that is x squared, I think I will choose here. Then if I differentiate that, I get 2x. So that means my v dashed function will be equal to e to the power of x, so v will be equal to also e to the power of x. So according to the general statement up here from the integration by parts method, that will be equal to u times v. U is x squared, v is e to the power of x, subtracted with the integral of u dashed, which is 2x, times v, which is still e to the power of x dx. So here we see that something new compared to the first two examples I showed. We have still two functions multiplied here. So what we simply do is that we take it one step further. Again, we define for this small integral here u as the function which is easy to differentiate, so that will be 2x. When I differentiate that, I get 2. So v dashed is equal to e to the power of x, meaning v must still be equal to e to the power of x. So then we continue with what we have over here. Still the x squared times e to the power of x, subtracted with, and then you remember brackets here because you have a minus in front. So if you don't include the bracket here, you will end up with some mistakes in your signs. So remember to include the bracket here, and then we do integration by parts for this small integral here. So that is equal to u times v, u being equal to u being equal to 2x, and v being equal to e to the power of x, subtracted with the integral of u dashed, which is 2, times v, which is e to the power of x dx. So now we have a small integral with only one function, e to the power of x, which we can solve. So let's do that. X squared times e to the power of x minus, and I will get rid of the bracket at the same time, so that leaves me with a plus in here, 2 times, and the integral of e to the power of x is e to the power of x plus c. So here we have it, the result to the original given assignment up here. So at the very end, or in this time the second time we did integration by part, the first derivative of the function u was a constant, and then we could solve it like we saw in the first two examples. What we actually did here can also be illustrated on a table overview. So let's illustrate that over here. I will make two columns. One for the function which I'm differentiating, that is the function we label u, and one for the function which I'm integrating, that is the function we label v. So then I put in from the original given assignment up here the function which I've labeled u, that is x squared, and the function which I've labeled v, which is e to the power of x. And then what I do is that I will differentiate the function here until I reach 0. So that is the first time I differentiated, I get 2x. 2x differentiated is 2. 2 differentiated is 0. So that took me 1, 2, 3, 4 spots to do that. The same amount of time I integrate what I have over here, and that's quite easy because e to the power of x integrated is just the function itself. And then what we actually get here is that if we multiply these two numbers positively and subtract that with the product of these two numbers added with the product of these two numbers, exactly what we have up here. You see that? That x squared times e to the power of x is what you have here, minus 2x times e to the power of x, which is what you have here, plus 2 times e to the power of x, which is what you have here, added with the integration constant. So using this table overview here, we actually quite fast can find the solution to this assignment given up here. I will just end this video with one example of an exercise where I just find the solution using this table form on my own. This final example I've chosen to include is to find the integral of x to the power of 3 times e to the power of 2x. So if we should create this table overview, which we talked about just before, we have two columns. In the left column I will include the function which I will differentiate, which is u, and in the right column I will include the function which I'll integrate, which is v. And the rule of thumb tells me that I should go for x to the power of 3 as the function u and e to the power of 2x as the function v. So then what I do is that I differentiate the x to the power of 3 until I reach 0. So the first time I differentiate it, I get 3x squared. Next time must be 6x, 6, and 0. And then I have to integrate the e to the power of 2x the same number of time until I reach 0 here. So that must be equal to half e to the power of 2x, a quarter e to the power of 2x, 1/8 e to the power of 2x, and finally must be 1/16 e to the power of 2x. So the result to this one here must be equal to positive product of these two subtracted with the product of these two, added with the product of these two, and finally subtracted with the product of these two. So altogether that gives me x to the power of 3 times half e to the power of 2x minus, and then the product of these two, 3x squared times 1/4 e to the power of 2x added with 6x times 1/8 e to the power of 2x, and finally subtracted with 6 times 1/16 e to the power of 2x plus c. So now I'm almost there already. I just need to simplify this a bit. What do I have here? I have 1/2 x to the power of 3 times e to the power of 2x minus 3/4 x squared times e to the power of 2x plus, then it must be 6/8, which is the same as 3/4 x times e to the power of 2x minus 6/16, that must be the same as 3/8 e to the power of 2x plus c. So already here I'm done. I have found the solution to the given integral here. Yes, that is the most basic thing on the method called integration by parts. Thank you for watching.